All right, so we're going to continue, probably finish up with OOP today. I did post an update on assignment 2, so make sure that you're out there, you're reading that. There is an opportunity for me to provide some starter code so that you're not sunk on assignments 3 and forward. I was working on it right now, and I will definitely have it by the end of the day, but you need to contact me at some point to get that starter code. With the conditions on there. So let's see, make sure that this is working. Yep, we're good. All right, so to continue from last time, we very briefly introduced parameterized polymorphism. And you already know about parameterized polymorphism because we covered things like, say, lists. This is a list of accounts, right? This is a list of savings accounts. This is a list of annuities. And so that Langle-Wrangle right there, that's the parameterization. But you can do that as a programmer as well. You could go ahead and have parameterized variables, t sub x. What variable type is x? The type is variable itself. It's type t, right? That's just a placeholder. You can do that for methods, and here's the syntax. For example, if I want to get the maximum value, right? The maximum value in a list of numbers or something like that, right? Do I need to write a getMax function for integers, a getMax function for doubles, or even a getMax function for strings? No, it's the same function. It's just applied to multiple different types. And we'll take a look at that as an example here. And then finally, you can do your own classes, which you'll be doing in your Lab 6 this week, right? Where you are going to be doing an enrollment system, but then you want to make sure that this section can only be grad students, that section can only be undergraduate students, etc. What I want to do to motivate this and show you how it works is I want to write a function to sum the values of all of our accounts. So we've got 4 accounts here, 2 savings accounts and 2 annuity accounts. We've got a list of accounts, we've got a list of savings accounts and a list of annuity accounts, okay? So my first attempt here is, let's go ahead and do it for a list of bank accounts, of just all accounts. So public, double, get total, right? Or sum total or something like that, right? And I'm going to take say a list of accounts, right? Accounts. There we go. And I'll do the obvious thing here. Double total is initialized as 0. I'll eventually return the total. There we go. And what I need to do is I need to iterate over each account, so an enhanced for loop here, for account A in the collection accounts. I will simply say total plus equals A dot get value, right? And that will work for my accounts. Let's go ahead and show that it will work. Let's go ahead and capture that value. Double result is equal to get total is what I called it, my accounts. And let's print that out. System.out.println result. Right? Did I not call it get total? Okay. Accounts. What are you complaining about? Oh, did I not make this static? Sorry. Public static. There we go. All right. And let's run this, and I don't know how much money do I have. $67,500. Awesome. Right? So it works. But what's going to happen when I want to, say, do a list of savings accounts? Let's go ahead and try it. Result is equal to get total of all my savings accounts. And print that out. Uh-oh. Get total. Get method total get list of accounts is not applicable for the arguments of list savings. Why is that? We'll understand that here in a second. Before we understand that, though, I don't like lists. There's no reason that the first 2 should be the savings accounts. There's no reason that the first 2 should be, the second 2 should be annuity accounts. Maybe I've got a set of accounts instead. Right? Let's go ahead and get rid of this down here first so that it compiles again. And this is going to be a hash set. Oops, hash set. Right? And bring these in, import and import. There we go, there we go. Done. Hey, that code that worked before now is broken. Why? I have a set of accounts. What does it expect up here? A list. So my first step is to apply subtype polymorphism. Sets, lists. What are they both? Do you remember the yeah, the collections, right? Let's see the truncated version here. There we go. Let me bring this up over here, right? So if all you're going to do is iterate over the collection and call a method on it, right? Does it matter that it's a set? Does it matter that it's a list? No. Let's promote it, that type, up to a collection so that we can do whatever we want with whatever we want. Collection of accounts. And after I import that, did I have to change a single line of code in this thing? No. It's polymorphic. Now it applies to collections, sets, and lists. And moreover, it applies to hash sets, tree sets, array lists, linked lists. Right? And I only had to write one function to do that. Right? And it still works, whether or not it's a set, or let me go back to a list, an array list. There we go. And it will still work, no matter what type of collection I have. Now in the future, if somebody comes up with a brand new type of collection, right, ordered hash list or something like that, some random thing like that, and if they put it into this hierarchy, do I have to change any of my code? No, it'll still work. Right? It's on them to be able to provide the necessary components to treat it as a collection. That's a good first step, okay? Now let's come back down here and see if that solves my problem. Get total. Nope. In fact, if I wanted to do this for my annuities as well, right? My annuities, there we go. That's not going to work either. Right? Let's come up here and think about this for a second. This is a collection of accounts. Well, wait a second. When we were talking about function overloading, remember that we could define multiple functions with the same name, math.abs here, that applies to a double, an integer to a long, et cetera, right? You remember that demonstration? I see the same thing here, right? I see the same thing in that, well, wait a second, you wrote something that applies to an account, and, well, a savings account is an account, an annuity account is an account, so why isn't this working? Right? So let's go ahead and cut and paste this and see if we can get it to work. Not just for accounts, but for, say, savings accounts and for annuity accounts. There we go. Right. I should be able to do this just like math.abs, right? There are 4 abs in the same class. I should be able to have 2 getTotal functions because these are different types. This is a collection of savings. This is a collection of annuities, right? Well, that's where Java history comes in. This was the parameterization was only introduced like 5 years after Java was born, in 2001, 2002, or something like that. And one of the design principles of Java is to bend over backwards to be backwards compatible. So when they introduced these things, what they could have done is said, all right, we're going to go ahead and break all previous Javas, and we're going to have strong parameterized polymorphism, where you can do something like this. And when it gets compiled, the compiler will check everything, but also at runtime, it'll ensure that these are savings accounts and these are annuity accounts, and you can have these 2 functions just like you have 4 math.abs functions. That's not the way that they went, because it would have broken all 5, 6 years of previous Java. So what they did was a compromise, and it's called type erasure. In fact, if we hover over this, we'll see erasure of method getTotal is the same as another method. The compiler is not able to figure out the difference between these 2 functions because of the way that it compiles. The compiler will go through and check to make sure that you are passing in the correct types, but after it's done checking, it will erase those types. This is what we mean by erasure. Let me go ahead and show you what I mean explicitly. Let's get rid of this. Savings, sorry. It was not compiling because it was not misspelled. It was compiling for not compiling for other reasons. Let me go ahead and move the declaration up here so I don't have to repeat it. Result, there we go. And then get rid of this declaration. Let's go ahead and get rid of all of this because it no longer applies to general accounts. It does apply to savings accounts, but it doesn't apply to my annuity accounts. Right? This will actually work and run. $1,500, but I'm only doing my savings accounts here. Let me go ahead and open this up on the file system and show you how this is actually working. Oops. dang it, where was it? There we go. Cancel this. All right. You can see my source file right here. Right? All my .java files are in there. But when it actually gets compiled, it gets compiled to the bin for binary. Right? So let's go ahead and take a look at those. There's my demo class that I guess account demo class is what I want. That just was just compiled and just run. Let's go ahead and bring it over here. Oh, come on. Drag and drop. Come on. Drag and drop. There we go. All right. You can open up compiled Java source code. There's going to be a little bit of bytecode in there, Java bytecode that is incomprehensible and unreadable. But otherwise, there's going to be a lot of actual plain text here that you can actually decompile Java and get the original version back, right? The Java decompiler.com or something like that out there. But take a look at the signature for get total. It's a collection of what now? Nothing, because it got erased. It got erased so that it was Java would be backwards compatible with Java 1 through 4 or whenever they introduced the parameterization system. That was the great compromise that they made. Not every language does this. Some languages are okay with breaking things. Has anybody learned Python? All right, so Python, hopefully you learned Python 3, right? Why not 2? Because at some point they said, all right, there's just too many, hang-ups. There's just too many things that we never envisioned and that we've redesigned and stuff like that. So we're going to cut this off and make it so that 3 is not backwards compatible with 2. And then we're going to move on with our lives. And at this point, Python 2 is dead. PHP is like this as well. In fact, they skipped an entire version because of backwards compatibility. And so they break stuff all the time. Java wanted to be more like C, where C, you do not break stuff, right? Because, in fact, you don't even break stuff to the point that you do not introduce new or substantial new features at all, right? Every 10 years there's a new standard, but the new stuff is so small and far in between, right? Why? Because we want our stuff to work, right? We want our stuff to work going forward 50 years from now. And that's what Java, one of the design choices of Java made was we want stuff written in 1999 to be able to run in 2023 and in 2075 or something, right? And so they are backwards compatible, and that is the consequence. So what is a solution? Well, one solution is go back to the C world, right? And can you have 2 functions with the same name? Nope. So call it get total for savings, get total for annuity. There we go. Now, of course, I would have to change it down here, but is that the way we really want to go? No. That takes us all, that's kind of a regression back to the C world where you don't have strong polymorphism. So instead what we're going to do is we're going to parameterize these things, okay? I'm going to go ahead and get rid of the second version because I don't want to repeat myself. And then I'm going to put in a parameter here, T. What is T? T could be a savings account. It could be an annuity account. It could be something completely new, a checking account if we introduce that, right? And so that parameterization right there is saying that the type is variable. Fill in the blank. If you call this with a collection of savings, then I'll go ahead and put in savings here. If you call this with a collection of annuity, I'll go ahead and put in annuity there, right? I don't want to do either one. I want to keep it general, all right? Now there is a problem here. What is T? If I create a variable called T, and I'll call it X here, and I can do that now that I've got this parameterization, what type is X? It doesn't know yet, right? Or at least it knows one thing. It knows that like everything else in Java, it's an object. This is no different than creating what are called raw types, object Y. You can do that, right? What can you do with Y? Well, you can print it out because everything has a two-string method. You can compute its hash code. You can do whatever another object can do. You can get its class, you can say dot equals, et cetera, right? This is because this is built into every single object in Java. I don't have enough information though, do I? What information do I need? I need to know that it's at least an account. I don't care if it's a savings account. I don't care if it's a an annuity account. I don't care if it's a new checking account, right? I just need to know that it's an account because I need to be able to call this get value method right here. So what I'm going to do is I'm going to add another minimum piece of information here. Extends account. That additional piece of information there ensures that whatever type T you give to this function, it's a subtype of account. That solves my problem right here. Solves my problem right here, solves my problem right here, and it also solves my problem right here because an account, of course, is certainly extending itself, right? Now I can do this with a list of savings, I can do this with a set of annuities, I can do this with a list of accounts. What can't I do this with? A list of strings. Names is equal to arrays dot as list, hello, world, Joe. There we go. Could I pass that in and get a result from get total? Nope. Right. Why? Because a string is not a bank account. Right? It does not have the get value function that I would expect from it. The type safety is checked at compile time, and the compiler says, "Wait a second, I'm looking at this this get total, and you can pass in an arbitrary type here, but it has to extend an account, right? And a string doesn't do that. So compiler error, you cannot do that. Right. All right, let's come back up here. This is pretty damn general, right? This is basically what you want, except that did I actually create a variable called t anywhere? Tx? No. This is what's called a named parameter because I actually gave it a name. The name is t. I don't care about the name. You can make this even more general and don't give it a name. Question mark, right? That's a nameless parameter. That's called a wildcard. Now the syntax is a little bit different because you don't put the parameterization on you put the parameterization on the collection here. Right? Now, that is as general as it gets. If I go any further, then I lose information that's necessary. Right? This is a collection of, well, a collection of what? I don't know, I don't care. All I know that is that everything in that collection is an account, and therefore everything in that collection has a get value method. I could treat them all like accounts. I don't have to treat them like savings accounts or annuity accounts or whatever. That is as general and generic as it gets. Okay? All right. Questions on that demonstration? Then let me open up. Yeah, go ahead.
Is the purpose of using the question mark kind of just not have to name something?
This gets into PACS, which is what I'll talk about here in a second.
Okay.
It's a design principle. Basically, yes, if you don't need to refer to it as a name, then don't, because it makes it a little bit more general, a little bit more flexible. Right? Yeah?
I know in some languages they use underscore for like not named stuff.
Which language are you thinking of?
I know Lua does it, and also Swift does it.
Yeah, I'm not familiar with how they do it. Underscores usually denote, don't touch this because it's private. I know you can touch this, but don't touch it anyway because I put an underscore in front of it. And if you touch it, then, yeah, the C does this as a convention, not as a rule. Python does that. PHP does that. Basically, in any language where you don't have strong encapsulation to protect variables using private variables, they use underscores in front of stuff to tell you don't touch, don't look, right? But Lua and Swift, I don't have much. So you do Roblox or something?
No, there's a video game I play called I think it's Retro Gadgets, where you can like build gadgets and then you can program the CPU on it.
In Lua?
Mm-hmm.
Oh, okay, all right. I just know that Lua is popular because it's Roblox, right?
It is Roblox.
Yeah, there we go. All right, so this is one time that I will go to pre-prepared slides here because I don't want to type everything. And it's not that important. Do not think that you have to have good, what do I want to say, good, like really strong polymorphism in your projects. We do not expect that at all, right? Let me, come on, parameterized polymorphism, there we go. And let me bring this over here. All right, so here's the usual type of parameterized polymorphism that you're familiar with. You know, array lists, you parameterize it and you get stuff done. C++ has very similar syntax, but it's not the same thing. In C++, actually, more and more, it generates additional copies of code for each type that you apply it to. In Java, it uses type erasure, and so gets rid of your types when it actually compiles, and there's only one version of it. Here's an example, another example, where I have that getMax function. Right? And here I do need a named parameter. Why? If I have a collection of t's, you want me to find the maximum value, I need to pull it out and give it back to you. Well, what type should I be giving back to you as a return type here? T, right? There's where you have to use a named parameter. Because if I give you a collection of integers, you're going to be expecting, I'm going to be expecting an integer back. That has to match. So here's the parameterization, T. Its return type is T, and it takes a collection of elements of type T. If you gave me a list of strings and I expected a double back, right, these T's won't match up, and it'll be a compiler error. Right? The actual code to do this is we get the first one. We assume that the first one is the maximum. And then for each element in that collection, we use some criteria to say, is this thing greater than this thing? If so, then this is our new maximum. Right? Now, this is not real code here. Why? Again, do I have any information about T other than it is a object? Nope. So there's really not much I can do here. I can print it out, but that's it. Right? So here's my second solution. Where is the second solution? There we go. I'm just going to jump down to this. We'll come back to that other stuff here in a second. GetMax, I'm going to go ahead and give it a minimum amount of interface here. I'm going to say that your T's are numbers, right? And that means that I've got a collection of T's. This now applies to any list or collection of integers, doubles, floats, or some mixed type there. Right? And now what we can do is we can dump that to a double value and then make a comparison. Is this thing greater than this thing? But that's still not very satisfying, is it? Right? I mean, what about strings? Could you do this with strings? Could you convert a string into a double value? No. So we have yet another extension here. Instead of saying that they're extending numbers, I'm extending a comparable interface. Right? In other words, they have this compare to method now. And I can take this thing and say, oh, this thing is greater than this thing, that thing. So there's my new maximum. Right? Now this will apply to numbers, integers, doubles, and strings, or anything that implements the comparable interface like, say, person. Right? You can get the maximum person based on their last name. Right? That's still not as far as you can go. Let's take a look at how Java does it. Right? Collections.max. Right? Let me jump to that. And not this one, but this one. So there's my collection. We'll talk about that here in a second. Here is my other thing, right? It's not comparable. It's not a number. Instead, what else? Here's your collection, and here's your other thing. What is that other thing? A comparator. That you take out two elements, and you want to know which one is larger than the other one. I don't even know what they are, right? Because they are elements of type T. They're not necessarily comparable. They're not necessarily strings. But I can give them off to this comparator over here, and it knows what they are because it has been parameterized for that type. And it can compare them and return something negative, positive, or 0. And if it returns something positive, then I know that my candidate for the maximum is the next is larger. Right? This is old school iterator pattern. Don't worry about that. But otherwise, it's basically the same thing. Right? I get the first one, and then I'm going to go through all the other ones and ask, is that even greater, is that even greater, is that even greater? And then I return the candidate here instead of, they didn't call it max. Let's look at the parameterizations for this. First of all, it's parameterized T for any type. It returns an element of type T, the same type. It takes a collection of, I don't know what they are, I don't care, I'm not even going to name them, but they extend T. Right? It could be any subtype of T. COLL collection, short for collection. Right? And then the comparator here, this provides what's called an upper bound. Right? This gets into what I said before. This is PEX. Right? This is producer extends consumer super. Let's go back to our notes here so I can put that in there. Let's see. All right. So when do you use this wildcard? When do you not use the wildcard? When do you use a lower bound? When do you use an upper bound? So a collection is a producer of elements. If you're going to pull stuff out to do something with them, right? You're going to print them or something like that. And that's when you use a named parameter, t extends item. That's what we mean by producer extends. If you're taking stuff out of the list to do something with it, or you're taking something out of the collection to do something with it, then it's a producer, and you use extends. If it's a consumer, if you're going to take these things and put them in to that stuff, then it is a consumer of elements, and you use the super keyword with the question mark here. If you don't care about what's in the collection already, you just want to put stuff in. Here's another example, or a series of examples. Right. What can I do with stuff in that list? What can I do with stuff? Right. This is basically no different than a raw type. Question mark. There's no name, there's no information about it. All I know is that it's an object. I can get the first one. What can I do with it? I can print it out. That's it. Now we've got a name for it, right? Instead of using a raw type and calling it object, I can now use this parameterization and say that, well, it's of type T. I still don't have any information about it, but at least it has a name now. Now, if I put in an extends keyword here, T extends bank account, I have a minimum amount of information here. Right? I know that everything in this accounts list is a bank account. Therefore, I can treat it as a bank account and get the balance of it all. But again, we didn't really use T, did we? So question mark extends bank account, and we don't have to change any code because I never said variable T whatever. But if you do need to do it because you want to use the CS of PEX, right, the consumer super, then you need to do something like this, right? T extends bank account. And if the balance is is non-zero, right, if it's a positive balance, what we'll do is we'll take this other account and we'll add it to your list of accounts. There I need a named parameter because that account has to match that list of accounts. Right? You can always use both of them. Right? We didn't really use the fact that this list was a list of bank accounts of T's. So the full PEX here, producer extends consumer super here, where I'm using question mark super of T because this acts both as a producer and a consumer. I pull stuff out, I look at and see if there's a positive balance, and if so, I put it back in, or I put this other account into it. Right? So this thing right here is acting as both a producer and consumer, but you get the idea. Right? If you want to read more, there's some links on it for this, but again, we're not expecting this at all. Right? If you take a look at this, this was super well designed. Right? This was a lot of people thinking long and hard about this, and how can we make this as general as possible, but not too general so that it actually works and we have information about it. Right? I would not expect anybody here, and myself included, to design this in a day without input from other people. Right? So we're not expecting you to do this kind of hardcore parameterized polymorphism in your classes. In fact, I wouldn't even say use parameterized polymorphism in your project at all. You'll get exposure to how to do it in your lab this week, certainly, but using it in your project is probably Yagni. You ain't gonna need it. All right, any questions on that? Otherwise, let's go back over here. There we go. We're gonna finish up with the solid principles. Now, these are basically just the idea, the 4 pillars restated as best practices, right? It's an acronym. We like acronyms. We always put acronyms together, right? Let's see. Yeah, we'll stay over here, right? So what's the single responsibility principle? It's just simply a restatement of good encapsulation, right? A class or method should be responsible for one thing and one thing only, and it should do it well. A violation of this would be don't have God classes, right? If you have a God class that does everything, sees everything, is everything, that's a violation of the single responsibility principle. One of the violations that we saw, even though I think we explicitly mentioned it, is, loading data, saving data as XML, saving data as JSON. How many things does that sound to you? At least 3. right? So should you put all three of these things into one class? Probably not, right? Separate them out into different classes. We were looking for a minimum of 2 classes there, right? So that you separated out responsibility. Another obvious example, I don't think anybody did it like this, but a person class should not be should be responsible for person things. An address class should be responsible for address things, right? So if you didn't have an address class, that was probably, I think, 5 points off or something, right? Basically, don't repeat yourself, right? Why would it be a good thing to have an address class? A person has an address, but what else has an address? Store, right? You're not repeating yourself. But then, would you put that into an inheritance hierarchy? Is a store an address? Is an address a store? That doesn't sound right. Is a person an address? Is an address a person? That doesn't sound right either. So what do? You use composition, right? And reuse that class right there. Just like a local date, you don't roll your own. You don't make your own local date. You just use what's built into the language, right? All right. The open-close principle, right? That's the solid SOLID, right? The open-close principle is that every unit module class should be open for extension, closed for modification, right? That means that whatever general behavior belongs in the superclass, right? Specialization belongs in the subclass, right? Do not mix them. Specialization, I didn't spell it right. Specialization. All right, there we go. All right, do not mix them. For example, let's come back over to our Eclipse here, and let's reconsider how we did. I mean, we did it correctly the first time, but let's reconsider how we did get value here. Right? What I did is in the superclass, I didn't even bother defining that. I made it abstract because I didn't even want to answer that question. Right? What is the value of an account? I don't know, right? I could return 0 as a flag value, but I don't even want to answer that question. So I made it abstract. What if we didn't do that? What if we did something else? What if, for example, we did private final string type, where A means annuity and S means savings. And then I put this specialization in the superclass. I did something like this. If this dot type is dot equals A, then the annuity stuff happens here. Right? There we go. Oops. Return something like this. Right? Now, to do break encapsulation further, right? Because what I have to do is I have to get the monthly payment, and I also have to get the number of years. Right? Else if this dot type dot equals S, then it's return this dot balance. There we go. Else if, else if, else if. What am I doing every time I introduce a new subtype? I am breaking the superclass. I have to go back to the superclass and implement more stuff, That is a violation of the closed principle, right? That superclasses should be closed for modification. If you design a good inheritance hierarchy, you should never have to change the stuff up here. You should only ever introduce new stuff down here with specialization. If you put specialization in the superclass, you've kind of defeated the whole purpose of inheritance to begin with. Not only that, but how do I get access to the monthly payment? A subclass can always get stuff and because it inherits it from the superclass, but it doesn't work the other way around because this up here is not even aware of its children down here. Right? It's a bad parent. Right? So don't do stuff like this. This is a huge violation of the open-close principle. Abstract. Restore that, and now all is right with the world. In fact, should you even have something that looks like this? Typed. Why do you need that? Right? Well, you need it to print it out so that you get a good XML or JSON or something like that. Fine. Don't do that in next phase. Right? We didn't take off for that in the first phase for having something like this, right? But we would definitely take off in the next phase for having something like that. Right? All right, now it's all restored. Another aspect of the, again, no, if there, here, I'll put this in there at least. If there is no general or default behavior, make sure that you're defining it as abstract. And the thing here is that you need to have a well thought out inheritance, because it's extremely difficult to change it once you're locked into that inheritance. Remember this inheritance over here with the collections library? Let me pull that up. Where is inheritance and then the collections hierarchy? Right here, right? This was really well thought out, right? Because they knew that if we screw this up, we're going to be dealing with this for the next 20 years, right? However long Java exists. Now, they didn't get everything right, checked exceptions. They didn't introduce strong polymorphism to begin with, and so they had to have compromises on that. Design is never perfect, but this is as close as it gets, because I don't think that anything has broken here in the last 25 years. Right? They had a well thought out inheritance hierarchy here not from day one, because collections were introduced in Java 2 like 2 years later, right? But this works, right? This is a rigid hierarchy, and if they had made a mistake here, then 20 years later we would still be dealing with that mistake. Right? And so don't lock yourself into a rigid hierarchy. In fact, in general, you might see this statement: prefer for composition over inheritance. When in doubt, probably don't want to go with inheritance. Right? Now, in your project, it was designed specifically so that it would be obvious where the inheritance should be, and so you should have inheritance, but you could have composition and inheritance together in some acceptable designs. The other aspect of this would be closed for modification. The example of an integer class. The integer class has been made closed for modification by making it final, because we do not want anybody changing what it means to be an integer. We don't want to have people have 3.5 as now an integer, or an integer plus an integer actually means subtraction or something like that, right? Not good, right? The L is actually, we've already covered it, is the Liskov substitution principle, and it's stated as follows: that if S is a subtype of T, so we've got S and T, then objects of type T may be replaced with objects of type S without altering any of the properties of T. Right? Example. So here, I'll just pull this over, since we've seen it many times before. Here's a good example of a good L. Right, there we go. This is a good Liskov substitution principle application, because if you've got an array list and a linked list and just a general subtype polymorphism, some list, it could be numbers. Some list could be the other numbers instead. Right? That's good, because making those two changes right there, that does not change the behavior. Right? You can substitute that in all you want, and it doesn't break anything. What about the example that we looked at before? And I'll pull it from, I just had it in another section. Here we go. I think we looked at this, did we not? Rectangle, shape, square. Right? And I put it into this inheritance hierarchy. A square is a rectangle, mathematically. A rectangle is a shape. A square is a shape. So this all looks good, except that we've got these setters over here. If I create a 5 by 5 square, and then I change its width so that it's now a 5 by 10 square, is it a square anymore? Nope. You cannot substitute a square for a rectangle, or a rectangle for a square, or whatever, because of the way that you design that class. So that's a violation of the Liskov substitution principle. Right? Generally, prefer immutable objects, and you don't have this problem. Generally don't have an inheritance hierarchy that is sometimes correct, sometimes wrong, right? Your inheritance hierarchy always has to follow that is a relationship, right? A square is a rectangle, and as long as you can never change that square into a rectangle, then fine. But otherwise, If it's changeable, and sometimes it might be correct, sometimes it might not be correct, then don't put it into an inheritance hierarchy. Prefer composition over inheritance. Right? I is the interface segregation principle. And that simply means that and no client code should depend on methods that it does not care about. So here's an example that I always use. Suppose that you are writing a graphical user interface program. Right? And there was some debate about this in my other section, so I'll ask you. There's a button that says save, right? What do you do to that button to save? You click it, right? Does anybody ever double click a button?
Depends on what it is.
Oh, okay, what kind of button would you double click?
It's maybe more like a video game thing, but yeah.
Oh, a video game double click? Like what game would you like a file, to open a file, you double click the file.
Yeah.
That's obvious, right? But a save button? I don't think anybody would ever do that. And this has actually been an issue, because if you look at the grader, if you hit grade, we won't show it now, but I've had to put in additional code that then disabled the button on the first click, because there were so many damn people that were double clicking that grade me button and sending 2 requests to the server and causing a race condition. And so my solution was to simply just not allow double click by graying that out and disabling it, so that only after you got your response back from the server did it then activate again, right? Because people were double clicking I thought only like, senior citizens did that, but it was definitely an issue enough that I had to put in that additional code there.
Was it causing like bad performance, or was it just like causing a bunch of extra requests?
A bunch of extra requests, but then there was a race condition, because then the first one would come back, or there would be compiling on the server, and then they would, step on each other's toes, and file locks and, stuff like that. So there were definitely back-end issues because of it. And so my solution was just, all right, no, you're only allowed to click this once, right? But imagine if you had a click event handler that forced you to define both of those, on click and on double click. Well, on click, I'll go ahead and put in the code to save the file in that one method. Right? Now what do I do about that other method? Do nothing. On double click, do nothing. Throw an exception. This is an unsupported method exception. Right? Duplicate the code. Copy, paste. If you click it, great. That'll save the file. If you double click it, it'll save the file. Right? Don't duplicate my code and have the on double click call the on click method. None of these seem like good solutions to begin with, because, again, should I have to answer that question if I don't want to? Probably not. So the idea here is keep interfaces as small as possible, so as not to force the client code, right, the code that is writing this and implementing the interface, to implement stuff it doesn't care about or doesn't have a solution for. I don't know what should be on a double click event. I'm not even going to bother answering that question. I'm going to take it and I'm going to split those two into different interfaces. You see the same thing over here. I can guarantee you that most of these interfaces are 1 or 2 methods at most. In fact, some of them are 0 methods. Random access has no methods defined in it at all, right? So this is keeping interfaces as small as possible so that you don't force things to become things that they're not, right? If I had an interface that assumed something was a list, and then the set wanted to use some of it, it would force the list to behave like a set just because of my bad interface design. Right? That's the I, interface segregation principle. Make them as small as possible and separate them out. Right? The last one is actually the coolest, I think. It's definitely the most useful. Dependency inversion principle. Don't think of inverting things, but like flipping them upside down. I've got a better picture for it. But high-level modules should not depend on low-level modules. They should both depend on abstractions. And for us, that means an interface. Right? Where's my dependency inversion? There we go. I just grabbed somebody else's. This is not mine. This is one of the top hits on Google image search or DuckDuckGo image search. So there on the left is without dependency inversion. We've got a high level dependency. This depends on a low level thing. What we're going to do is we're going to separate those out. It's not like high level, low level, and then we're going to invert it. Don't think of inversion like that. Instead, think of it as we're going to separate them and then put something in between them. That something in between them is going to be an interface. Okay? Now, as an example, then this is an actual example that you're going to be using later on. Example. We write an app to connect to a MySQL database. All right? Great. With very specific methods and functions to connect only to a MySQL database. Right? MySQL is great. It's free. It's free as in beer, not free as in freedom, meaning that you don't have to pay for it, but you don't have the rights to it. A Postgres database is free as in freedom. In other words, it comes with a GNU GPL license where you can do whatever you want with it, including package it and sell it. You can't do that with MySQL. It's closed source. Requirements have changed. We now want to use a Postgres SQL database. So what's going to have to happen? Since we wrote everything very specific to a MySQL database, we have to rewrite everything. Rewrite everything to connect to a different type of database. Right? Sound like a good idea? That's without dependency inversion, right? Better solution? Have a common interface, database interface, right? So that you write one set of app code that connects to a generic database. And then what you can do is you can drag and drop what's called a driver, right? So MySQL publishes a driver, a JDBC driver in Java. And all we have to do is take this jar file, put it over here, we're done. Now we're connecting to a MySQL database. Because we wrote towards the interface. This driver implements this interface. Our code depends on the interface. Dependency inversion. Right? There it is. Right? Their code, implements that interface, and our code over here references that interface. Now all we have to do is take this package B, throw it away, and put in whatever Postgres publishes that implements that interface, and we didn't have to change a single line of code over here in our app. Right? That's dependency inversion. Right? There's another example that I have, but if we've got time, we can do it. Right? Anyway, inverting here, let's go back over here. Inverting a dependency means that you're creating an interface between the high-level object and the low-level library that implements it. In general, you should prefer loose coupling so that software components can be interchangeable. And this is not just with classes and interfaces. This is with everything, right? We do multi-tier architecture. You've got a database tier, a middle tier, and a front-end tier, right? And you want the very loose coupling between these so that you can have an Android app team develop the Android app interface to your business. iOS team doing Swift. They do an interface for iPhones or whatever. But your middle tier here, it doesn't change. Right? It doesn't change just because it's on an Android phone or an iPhone, right? Instead, these tiers up here change, right? And you have loose coupling between them. You have a common middle tier or a common API or whatever to connect to. Right? Believe me, it is freaking awesome once you've got a great API like that. For example, Canvas. Right? In fact, many years ago when UNL was deciding to, UNO uses Canvas as well, right? Right. So many years ago, we had basically salesmen come in. I think it was Moodle, I think it was Canvas, Blackboard, and somebody else because they were using Blackboard at the time. And they came in and they asked everybody to come in and listen to all presentations. And at the, I listened to all their presentations, and at the end of the Canvas one, it was obviously a salesman, not a tech person, because at the very end of 1 hour presentation, oh yeah, and also Canvas has a RESTful API, right? And so I immediately raised my hand and I said, look, you're talking to a technical audience. That's what you should have led with. You just won the bid. I didn't. It was not my decision. So, but in my mind, if it were my decision, end of story right there. You have an API. If you have an API, you can do anything. Right? For example, an application programmer interface. Right? What is Canvas's API? Canvas. .unl.edu/v API, is it? API v1, I don't want that, I want this. In other words, you could write a Python script. Oh, come on, am I not logged in? All right, I am logged in. Live, is it? There we go. Nope, Canvas live. Should be there. There we go. You could write a Python script. You could write a PHP script. You could write a Java app that connected to Canvas and got all of your, say, assignments. Right? There. This is a RESTful API. REST is representational state transfer, and it all works through HTML. You can delete an assignment, you can get an assignment, you can update an assignment, you can create an assignment or edit an assignment, right? This is basic CRUD, create, retrieve, update, and destroy. You can do this all through this API right here. How do you think I pull grades? How do you think I automate the lab grading? How do you think I do everything with Canvas? I write a script to do it for me because I am not doing that crap for 200 people in the main section, right? I try to automate this stuff as much as possible. And it's only possible if you've got dependency inversion. If instead I joined the Canvas team and I wrote a Java app that only worked on Canvas, that only did stuff on Canvas because that was their code base, I'd be locked into Canvas. I would not be able to write it in Python. I'd be locked into Java, basically. I would not be able to write Python scripts to do it. I would not be able to write I used to use PHP instead, PHP scripts to do it. Right? Instead, this is a general generic API. As long as you've got a way to connect programmatically using HTTP, you can get all of this stuff. And by the way, as students, you can do it if you want to. You're only going to get access to your courses and stuff like that. So, and your assignments, not to your neighbor's assignments or anything like that. You won't be able to change grades, obviously, but you can. Stuff like this is pretty powerful, and it's all because of dependency inversion. You put an API or an interface in between two things so that you have loose coupling. You could rewrite all of Canvas, like the user interface of Canvas in Swift on Linux, and just use this API, reuse this API. The other ones didn't have it, and I told the salesman at the end, I said, look, that's what you lead with, right? Because this is super, super powerful. Now, the administrators, the non-tech people in the audience, they're not going to know what the hell you're talking about. But this is the nail in the coffin on, like, for tech folks. If you've got an API, you're done, right? And unfortunately, I used to do a lot of stuff like way back in the day. Twitter had an open API. Reddit still has an open API, and a couple of other, like everybody was open about this stuff. And unfortunately, as the internet has progressed, people have locked stuff down. They've closed their APIs, or they've required you to, higher and higher burdens to connect to their APIs. One thing I've tried to do is like that book data that we've been demonstrating. I've tried to get book data from Goodreads. They shut down their API a couple of years ago. Does Goodreads support the use of APIs? They did, and then in 2020 they shut it down, and we're no longer allowed to get, book data from Goodreads. IMDb maybe have one where you can basically go and get all the data from IMDb programmatically if you want to. Right? And again, it is only possible because of this abstraction, an interface between two software components. All right? That's the solid principles, SOLID, right? Single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. And that'll all be in your exam and you have to memorize it. There's no exams. Right? Just remember solid, right? The way that these things usually happen is somebody thinks of the acronym and then they work backwards to make it, because you want the acronym to be cool, right? And then you work backwards for it. But these are things that have been developed over the years. Right? All right, nope, nothing online, no questions online. So any questions here? Then we're done with OOP as far as lecture is concerned. The next thing that we'll be doing on Thursday is SQL. And I've already posted on Piazza for week 6 on what you should be doing. The first thing that you should be doing is you should be getting your SQL account. If you go to cse.unl.edu/account, you log in with your CSE credentials. Nope. Yep, there we go. Go to account settings, and then down here it'll look a little bit different because you might not have an SQL account already. You can always come back here and reset it. That will send you an email with your a different password but the same login. Okay, the same login user ID. Then what I would do is I would suggest you can use whatever you want, but MySQL Workbench, the price is right. It is free. Download, install that. You'll create a new connection. Call it whatever you want, CSE, ECN, whatever. The host is going to be cse.unl.edu. That's a server down in Lincoln. Port, don't change that. 3306 is SQL. You are not root. I am not root. I wish I were root, but I'm not. Right? That's your login. Right? That's your login ID. And when you connect, it'll look something like this. Not this. But you are now connected to your database. You can start creating tables. You can use your database. Your database is named after your login. You can show tables. Initially, you're not going to have any tables. It's going to look more like this. Ignore this. Drop database cberg. I just deleted my entire database. Create database cberg. Great, now it's back. Use cberg and show tables. This is what it's going to look like for you. Right? There are no tables, right? Because you need to start creating them. And that's where we'll pick it on Thursday. We'll start talking about basic SQL, structured query language, which is what I'm writing right here. How to create tables, how to put stuff into tables. CRUD, create, retrieve, update, and destroy. Right? How to put stuff in, how to pull stuff out, how to change stuff that's already in there, how to remove stuff from the database. Right? Any questions? Anybody know SQL already a little bit? Anybody? No? Okay, good. Then it'll all be 100% super new. Note that there are different dialects of SQL. There's, of course, it's not, what is Microsoft? Transact SQL, right? That's the Microsoft dialect, right? There's also a different dialect that Oracle uses. There's a couple of different dialects. I will show you basically the Latin of SQL that will work on any SQL system. Right? I'm not going to get into a vendor lock and vendor specific stuff because every vendor, you know, Informix from IBM or Microsoft, they'll introduce new features. Why? Because they want you to get to use their stuff and use those features so that it's really, really difficult to go shopping somewhere else. It's called vendor lock, right? You're locked in because the cost, then they can raise their prices because they know that the cost of changing to somebody else for cheaper, right, still exceeds the cost of just paying more for that same vendor. That happens all the time. Right? All right. I'll see you in lab today then.